Good evening, everyone. Can you hear me? Type S in the chat box if you can hear me. This course is mainly focusing on the structural design of RCC building by using Staad Pro software. We are going to use the Connect version of Staad Pro. And as a civil engineer, it is not a simple syllabus. It is a vast syllabus. In civil engineering, civil engineering is the vast syllabus. We will be having many things in civil engineering, like structural design, design of bridges. We have roads, dams, tunnels, towers. Many things are there. So we should feel proud to be a civil engineer, and it is a vast syllabus also. So before getting into the course, we should know the role of a structural engineer. A structural design engineer has to play an important role because the safety is the main thing. Apart from other aesthetic and infrastructure of the building and all, so it is very important, that is the safety. So that is mainly depends on the structural designer who is designing the structure. So we should know what is the role of the structural engineer first before getting to. So whenever a client wanted to construct a building, we will go to the architect to finalize the dimensions of the building, that is the plan of the building. Then it comes to the structural engineer who has to design the structure. It goes to the contractor. The contractor has to give the work to the site engineer, and then the site engineer has to teach the labor and get the work done as per the architectural drawing and then the structural drawing. So this is the workflow. So here our important role, the structural engineer important role is to design the structure. That is, the skeleton of the structure has to be designed by the structural engineer. Here you should understand the difference between what is architectural drawing and what is structural drawing. Architectural drawing mainly having the dimensions of the building, dimensions of the structure. That means the plan will be having the actual dimensions and then elevation, how the building looks like. So that and all will comes under architectural drawing, aesthetic view. Whereas the structural drawing includes the skeleton of the structure, how the structure needs to be supported according to the architectural elevation, like the column location and then beam layout, slab layout, everything will come in the structural drawing. That means overall skeleton of the structure and the loads which is coming on the structure according to the architectural drawing, that load has to be carried by the structure. So that needs to be decided by the structural engineer who has to design the structure properly to withstand the load which is coming on the structure. So I hope you all clear about the what is the role of the structural engineer. Type S in the chat box if you are all clear. Okay, good. Now let's look into the overview of this course. So this course is structural analysis and design of RCC building. So in this, the basic concept of structural analysis and design will be taught, and then you will learn the Staad Pro software from scratch, and detailing we use RCDC, and then along with these two softwares you will be learning the Staad foundation as well, and analysis and design of the RCC structure. We will take one real-time project and then we will do the modeling from scratch. We'll do the loading, we'll assign the properties, we'll do the loading, and then finally we'll do the design of the structure. Lateral load analysis, this is very important one. Lateral load analysis means the earthquake design and earthquake analysis, and then wind load analysis will come under this. So that we will do as per IS codes and standards. And finally, we'll do the detailing of the structural members, beam, slab, columns and foundations. This is the overview of the course. So now we know the concept we know the role of the structural engineer, and we know the overview of the course. So what is the importance of the course? Let's move on to what is structural design. Structural design includes structural analysis, and then it comes to structural design, and then it comes to structural detailing. As the name says, structural design, you cannot do the structural design directly. So before that, there are few steps you have to learn, and then finally you have to do the structural design. So these three are the major concept which you need to do in order to complete the proper structural design of a building. So structural analysis is very, very important before doing the structural design. If you don't do the structural analysis, you cannot do the structural design. And then finally, after designing the structure, you have to do the detailing. That comes in the form of drawing. So these three complete set includes the analysis, design and detailing. So this is the complete set of structural design of a building. This is one structural design form, structural detailing format, drawing format. So as a structural engineer, we must know what is structural drawing, and not only structural drawing, we should know how to study the architectural drawing as well. So for civil engineers, not only designing the building, in any structure if you take, whether it is a bridge or dam or tunnel or tower, whatever you design, you should know how to study the drawings properly. We people speak different languages in order to communicate each other. Similarly, for civil engineers, drawing is the medium of communication to understand what it says clearly. So drawing structural, not only for structural engineers, as a civil engineer, site supervisor, even the labor has to understand the drawing so that he can execute properly in the site. So that's why we will be having the site engineer, site supervisor. So they need to explain the labors with the drawing in order to execute the work properly. So everything will be in paper, in the form of drawing. So that is also very important. You must know about it, how to read structural drawing and architectural drawing, so that you can execute the work, whether it is a structural design or execution of construction of the building. So for that execution of the total work, you need to understand the drawings clearly. You all got my point? Okay. Now let me explain you how the structural design works. So let's divide into two parts. One is substructure and then superstructure. In substructure, what we will be learning is concept, codes and software. In superstructure, we'll be learning modeling, loads, analysis and design. So before getting into detail information about these seven things, we have seven concepts here. One is concept, code, software. These three are substructure, and under superstructure we have four concepts: modeling, loads, analysis and design. So before getting into these seven concepts, let me explain you what is superstructure and what is substructure. So this is very important. So when you take a structure, the structure which comes below the ground level, that is called superstructure. You all must be aware of column, footing, foundation. These are all the names which is oftenly used in structural design. You must be aware of that, I guess. Type S in the chat box if you are aware of it. Okay, thank you. So the structure which are all coming under the ground floor, below the ground floor, that is called superstructure. The structure which is coming above the ground level, that is called superstructure. Substructure will be having the elements like column and footing, and superstructure we will be having the column, beam, slab. So these are all the superstructural elements. Below ground level, whatever we are getting, that is called substructural element. So this difference you should know. So similarly, how we are having the structure as superstructure and substructure, similarly in the structural design concept also we can divide into these two parts, substructure and superstructure. Under this we will be having 7 concepts. These 7 concepts, let me explain you one by one what we are going to do with this. Under substructure, the first one is concept. So concept, structural concept. We have to understand clearly this concept because already we know that structural design includes the analysis of the structure. Okay, in under concept, what we will be having, we'll be having the structural analysis and then strength of material. Strength of material is also a very important chapter. I hope you all will be having in your syllabus or curriculum. Strength of material. How many? Uh, let's have a Q&A session later. Okay. So I'll answer all of your queries. Okay. I hope you all will be learning strength of materials. You all are studying strength of materials. Type S in the chat box. Okay, fine. So you are all aware of strength of material, structural analysis, and then structural design. So this concept includes these 3 things: structural analysis, strength of material, and then structural design. So in this first concept, in this we need to do the conceptual design first. That means there are many type of things are there. Like we need to first choose the preliminary size of the structural member. So that is the main thing. And then we need to choose the proper material. So that comes under strength of material. And then analysis and then design. So this is the concept. And then next, coming into code. As you know, we are following Indian standard codes. We have so many codes. We need to follow IS 456 2000 and IS 875 part 1 is for dead loads. IS 875 part 2 is for live loads, and IS 875 part 3 is for wind load, and then IS 1893 2016, that is for earthquake resistant structures. And then we'll be having SP 16 design 8, SP 34 but for detailing, and IS 13920, that is for ductile detailing, and so many codes we have. So that codes and standards we need to follow. Here we'll be having the question that why need to follow these kind of codes and standards, because they are the guidelines to the structural engineers. Like this is how we need to follow the structural design, and there are set of permissible standards, permissible limits are there in the codes. So that many research has been done, and then they finalized some of the permissible limits. So we need to do the analysis, and then we need to check whether the structure, whether whatever the analysis we have done or design we have done, that is satisfying that permissible limit or not. So that is very important. So in that way, we need to follow the codes and standards. I hope you all are aware about IS codes, right? Okay. So next, coming to the software. Here software plays an important role, because in olden days people were doing manually all the analysis and design, they were doing manually. How many of you feel structural analysis is a very easy subject? Structural analysis is tough or easy? Type in the chat box if it is tough, or if you feel easy, type easy in the chat box. Okay, I got a few responses, that is that they said easy, it is so easy. That is good. So in olden days, people were doing that analysis. Like it will take so many. It consumes more time, and there are many calculations are involved in that analysis of the structure. So now we have many softwares in the industry like StatPro, eTabs, Revit, and so on. So here we are going to use the StatPro software, StatPro Connect Edition, and then we are going to do the modeling, analysis, and design. So in this way, the software support for us to do the analysis and design of the structure. So these three are clear. Next, let's move on to superstructure. In superstructure, the first one is modeling. Modeling means like we need to model the geometry. Model the geometry using the StatPro software. Modeling includes modeling of the structural member, and then we need to assign the member properties. Member property means size of the structural members. So that we need to give, and then support, proper support we need to provide, and then we need to move on to loads. Loads includes dead load, live load, wind load, earthquake load. So we need to calculate each and every loads which is coming on the structure, and then we need to apply on it. And finally, we need to do the analysis. After analysis, we need to check whether it is satisfying the codes and standards. That's what we discussed before, the permissible limits, and then we need to go for the structural design finally. After that, we need to do the detailing. So once if it is not satisfying the permissible limit, then we need to redo the analysis again by revising the size of the structural member, or increase the material property, member property, material properties, and then we need to do the process again. So that's all about this concept, substructure and superstructure. I hope you all understand this concept. How many of you know these concepts already? Type in the chat box. Not getting any response. Can you hear me? All of you, can you hear me? Okay. So how many of you know these concepts already? Okay, good. Next, let's move on to the objective of structural design. So now you all have got an overview of the things like what we are going to do and what is structural design. That is clear to you now. The main objective of the structural design is to design the safe structure, economical structure and durable structure. So the structure has to withstand the load which is coming on the structure has to withstand loads which is coming on it during its intended lifetime without any damage or collapse of the structure. So that is the main objective of the structural design. So it has to withstand all the forces during its lifetime. This is the main objective of the structural design. So to do this only we need to follow set of procedures. So here structural analysis is the process which we need to do before doing the structural design. So structural analysis using strength properties of the material, that is the first step in the structural design. As we have discussed before, structural analysis using the strength of material, strength properties of the material. So that is the first step which we do in the structural design. So here I have the image frame image. So you will be knowing the members like structural elements, slab, beam, column, and if you and the below this column you will be having the footing. So as we discussed before, these all are called superstructure, and below this ground level that will be called superstructure. Sorry, substructure. Now let's look into what is structural design and what exactly is structural analysis, what we will do in structural analysis. So structural design is the process in which we need to do the safe and economical, we need to design the safe and economical structure. So that is the main objective of the structural design. So lifetime of the structure, if you take a lifetime of the RCC structure, that will be 50 to 80 years. So the structure has to serve its purpose during its lifetime without any damage or collapse of the structure. So when the structure is So when we construct a structure, there will be external loads which will be applied on the structure, and due to that external load, we will be getting the internal forces. Internal forces will be developed in the structure. This is very important. So that internal forces we need to find out by analyzing the structure. So using that internal forces, we need to do the structural design. So that due to the external load which is applied on the structure, when the structure is function, so due to that we will be getting the internal forces. So priorly we need to calculate that external loads and then we need to apply on it, and due to that external forces we will be getting the internal forces, and then according to the internal forces we need to design the structure. Let me explain you here. External loads, due to the external loads we'll be getting internal forces, and then due to the internal forces we'll be getting the internal stress, and that internal stresses will cause deformation. Deformation means the structure move away from its original position. So in order to avoid this kind of deformation, what we need to do, we need to do the analysis. We need to calculate the internal forces and accordingly we need to design the structure. So to avoid this, we are designing the structure.